Hello coders, I welcome you all. In this video, we are going to discuss our next machine learning project, calories burned prediction using machine learning. We are going to use a real world dataset available on Kaggle that you can see over here. You can download this dataset from Kaggle or from my GitHub account. Link is given in the description of this video. As you can see here, our dataset contains two CSV files, calories.csv and exercise.csv. I have downloaded this dataset in my local computer. You can do the same. So throughout this project, we are going to perform various tasks such as loading the data, data pre-processing, data analysis, and model training. To efficiently handle this task, we will be using functions. We will create different functions to carry out each step, providing you with an industry perspective. The main motive behind creating these functions is to provide you with a versatile machine learning template that can be applied to any other machine learning project. Additionally, we will employ a column transformer and a machine learning pipeline to streamline our process. Now first, let's talk about calories burned. Today, many people care about staying healthy, right? So they are following fitness routines. One important part of being fit is knowing how many calories you burn during exercise. Predicting this can help you plan your workouts better and reach your fitness goals. Machine learning models can be really helpful in figuring out how many calories you burn based on your personal details. Main objective of this project aims to create a machine learning model that can predict how many calories you burn during different exercises. The model will use information about you to give accurate predictions about calories burned. So let's get started. Let's first import the libraries that we require. So let's import pandas as PD. Import warnings and let's disable warnings as well. So for that we have to write warnings dot filter warnings and here we have to pass one parameter, ignore. Let me execute this cell. Now let's import other libraries. Seaborn as SNS. Also matplotlib.pyplot as PLT. From sklearn dot preprocessing, let's import standard scalar ordinal encoder. From sklearn dot matrix, let's import R2 score. From sklearn dot model underscore selection, let's import train test split. Also cross val score. Also k fold. From sklearn dot pipeline, let's import pipeline. From sklearn dot compose, let's import column transformer. From sklearn dot linear underscore model, let's import linear regression. From sklearn dot ensemble, let's import random forest regressor. From xgboost, let's import xgb regressor. Let me execute this cell. As you can see here, our required libraries are successfully imported. Alright, first things first. The first step in our journey is reading the data. So let's create one function for this. So we are going to call this function read underscore CSV. It will be our data loader. This function takes file path as an input and loads our data into a pandas data frame. So let me write pd dot read underscore CSV. And here we have to pass file underscore path. And let's return this. But first, let's write something about this function so that other users can understand what this function can do and which parameters including their types it takes. So this is called a docstring and we are going to write a docstring for each and every function that we create. So we have to write docstring in triple quotes in Python and let me write read data from CSV file and return a pandas data frame. Parameters file underscore path. As I said, this function takes the file path as an input, which is string, and path to the CSV file and returns pd.data frame. The loaded data, as I said, it loads our data into a pandas data frame. So we have successfully completed our first function, our data loader. Let me execute this cell. So let's check our created function. So we have to call this function as read underscore CSV, this one, with our two CSV files. Let me give name C to this calories.csv and let me write read underscore CSV and our second CSV file, exercise.csv. Let's give name E to this file. Let me execute this cell. As you can see here. So we can check this docstring in Jupyter Notebook by pressing Shift plus Tab after placing the cursor inside the parenthesis of this function here. And let me press Shift Tab. As you can see over here, our docstring. By looking this docstring, other users can understand what this function can do and which parameters, including their types, it takes. That you can see over here. So as I said, we are going to write a docstring for each and every function that we create. So as I showed you, we have two data sets that you can see over here, calories.csv and exercise.csv. So let me write c.head and let's display first row of this data set, and e.head. Let's display first row of this data set, exercise.csv, that you can see over here. As you can see, user ID is common between them. Therefore, we need to merge these two data sets based on the user ID column. So let's merge these two data sets. So for that, we have to use merge function of pandas and see this one, our first data set, comma, our next data set, E, on this particular column, user ID. Let me copy, let me paste it over here, and let me assign it to one variable. Data is equal to this statement. Let me execute this cell. Let me check. As you can see here, top 5 rows of our data set, and we have successfully merged our two data set that you can see over here. As you can see, our data set contains these many features. User ID, which is unique identifier for each user. Calories, our target variable that we are going to predict, representing the number of calories burned in kilocalories during an exercise session. Next, gender. Gender of the user. It's a categorical variable. It contains two values, male or female. Age. Age of the user in years. Next, height. Height of the user in centimeters. Weight. Weight of the user in kilograms. Duration. Duration of the exercise session in minutes. Heart rate. Heart rate of the user during the exercise session. As you know, a normal resting heart rate should be between 60 to 100 beats per minute. And this is our final feature, body temperature. Body temperature of the user during the exercise session in Celsius. So these are our features. Based on these features, we are going to predict calories burned. This one. Now we have our data. So we are going to create another function called data underscore info underscore statistics. So this function will provide us with a quick overview of the dataset, presenting general information and basic statistics for numerical columns. Let me show you this. So I'm writing functions in the same cell. Let's create function with name dataset underscore info underscore statistics. It takes data frame as a input. Let's first display general information about the data set. So let me write print dataset information. Print. We have to use info method of pandas data frame, and let's print statistics in new line. Let me write comment display basic statistics for numerical columns, and let's write print statement basic statistics for numerical column, and we have to use describe method of pandas data frame and new line. Now let's write docstring for this function display information and basic statistics about the data set. Parameters data pandas data frame as input data returns none because we are printing the information. Let me execute this cell. Let me copy our function name and let's call this function. So as I said, we can check docstring by pressing Shift and Tab key. As you can see here, our docstring. As a parameter, we have to pass pandas data frame that you can see over here. So let's pass our pandas data frame. As you can see over here, data information and basic statistics for numerical columns that you can see over here. So let me add S over here. Let me execute this cell and this cell as well that you can see over here. So total we are having this many rows with these indexes, and total we are having this many columns in our data set. As you can see here, column names, and in our data set, these many non-null values are present in this particular column. These many non-null values are present in this particular column. Likewise, as you can see here, D types column. In our data set, 6 column with floating point data type, 2 columns with integer data type, and 1 column with object data type. And you can see memory usage for our data set. As you can see, basic statistics for numerical columns. Let me take this particular column. Calories, number of rows, average value in this particular column, standard deviation of this particular column, minimum value available in this particular column. And these are percentile values, 25%, 50%, and 75%. Since in this particular column calories, 25% values are below this, 50% values are below this, 75% values are below this, and maximum value available in this particular column calories. Same for other columns as well. So this way we can get basic information about our data set and basic statistics for numerical columns using info method and describe method of pandas data frame that you can see over here. So we have successfully created our 2 functions. Now it's time to be data detectives. So we are going to create a function named check_null to investigate if there are any missing values in our data set. So we are going to create this function to ensure our data is as clean as possible. So let's create our next function. Let me write comment check for the null values in the data set. Let's create function with name check_null. It takes data frame as input. Let me write data, which is pointing to our data frame, and we have to use isNull method of pandas data frame dot sum. And let's store this result into one variable, null_counts is equal to this statement. And let me write print statement null values in the data set, and let's return null_counts. Let's write docstring for this function check_null. Check for null values in the data set. Parameters pandas data frame as input and returns pandas series, the count of null values for each column. Let me execute this cell and let's check our function. So here we are calling our created function, this one. Let me execute this cell. As you can see here, as I said, we have created this function to ensure our data is as clean as possible. And here you can see output is all zeros. It means there are no missing values in the data set. So we have successfully created our third function that will check null values in the data set that you can see over here. But our detective work does not stop here. We also need to check for duplicated rows in our data set. So let's create another function check_duplicates. Again, it takes pandas data frame as input. Also, let me write one comment, check for duplicated rows in the data set. So let's return data dot, we have to use duplicated method of pandas data frame dot any. So this function returns a boolean value, true if any duplicated rows exist and false otherwise. Let's write docstring for this function so other users can understand what this function is doing. Check for duplicated rows in the data set. Parameters pandas data frame as input data. It returns boolean value, true if any duplicated rows exist, false otherwise. Let me execute this cell. Let me copy this so we can run this function. Let me paste it over here. Let me press shift tab to check docstring of our created function check_duplicates that you can see over here. Check for duplicated rows in the data set. Parameters you can see pandas data frame input data returns boolean value, true if any duplicated rows exist, false otherwise. Let me execute this cell. As you can see here, our function returns false, indicating that there are no duplicated rows present in the data set that you can see over here. So we have successfully created 4 functions that you can see over here. Read_CSV, data_info_statistics, check_null, and check_duplicates. So now let's visualize our data with some cool graphs to perform basic data analysis. For that, we are going to create a function named plot_graph. Again, it will take pandas data frame as input. Let's write comment getting basic analysis for numerical and categorical columns. So we are going to generate histograms for numerical columns. and count plots for categorical ones. As you know, visualizations help us understand the distribution of our data. So first, let's select only numerical columns. So let me write data which is pointing to our pandas data frame. Select underscore d types method of our pandas data frame. NP, so we have to import numpy as np. Let me execute this. So we have successfully imported numpy. So here let me write np dot number dot columns. So this statement will select only numerical columns. So let me write num columns is equal to this statement. So we are going to plot histogram for numerical columns available in our data set. So let me create for loop. So column in num underscore columns. So let me set figure plt which is pointing to matplotlib. Let me set fig size of our graph 5,3 and sns dot this plot data, and here we have to pass this column one by one, and also let me set kd to true. Title of our graph histogram for column this one, and let's set x label column name and y label to frequency, and let me write plt dot show. Now as you can see, this code will display histograms for numerical columns. Also we have to draw graph for categorical columns. So let me copy this code, let me paste it over here. In place of this, let me write get underscore calls, and here we have to include columns with object data type, and here for column in cat underscore columns. Title to count plot for categorical columns. Here it will display column names. Here in place of frequency we have to use word count. Here count plot, and here we have to call with column. Let me execute this cell and let me execute this function once again. As you can see over here, our count plot for categorical column that you can see over here. As you can see here, our first histogram for user ID. This column is not necessary, so we are going to drop this particular column. Now next, histogram for calories, which is our target variable. We can say the data is positively skewed or right skewed, that you can see over here. When the distribution has a long tail towards the right side, then it is known as a right skewed or positive skewed distribution, that you can see over here. So our target variable or our target column is positively skewed, that you can see over here. As you can see, most of the values are between 0 to 50, that you can see over here. As you can see here, distribution for our age column. From this plot, we can observe that the age column has the mean value of 42, that you can see over here. And the data is positively skewed or right skewed. And most of the data points are in between 20 to 50. And we can see the oldest person in the data set is 79 years old. And the youngest is 20 years old, that you can see over here. Now you can see distribution of height column. From this plot, we can observe that the height data is normally distributed with mean value of 174, that you can see over here. As you can see here, distribution of weight column. From this plot, we can observe that the weight data is also normally distributed with mean of 74 kg, that you can see over here. As you can see, distribution of duration column. So from this plot, we can observe that the duration data is a low peaked data, that you can see over here. As you can see, distribution of our heart rate column. So from this plot, we can observe that the heart rate column is normally distributed with mean of 95 heartbeats, that you can see over here. Now our next column, you can see distribution of body temperature. So from this plot, we can observe that the temperature is negatively skewed, left skewed, with mean of 40, that you can see over here. And this is our categorical column, gender, number of male and number of female. From this plot, we can observe that the data is evenly distributed, almost 7,000 observations for both males and females, that you can see over here. So we have successfully created function for data analysis, that you can see over here, with name plot underscore graph, that you can see over here, that will perform basic analysis for numerical and categorical columns, that you can see over here. Before moving to the next part, I forgot to write docstring for this particular function. Let me write plot graphs for numerical and categorical data in a data frame. Parameters, pandas data frame as input data, returns none. Because we are plotting different graphs for numerical and categorical columns. It returns nothing. So let's move on. It's time to separate our features and target variable. So for that, we are going to create a function called separate underscore features underscore target. It takes two parameters, pandas data frame and target column. So this function will split our data into features, also called as independent variables, that we are going to store in matrix X, and the target variable, also called as dependent variable, that we are going to store in vector Y. So let's write X. So X contains all the columns except the target column. So data dot drop. Let's drop target column and let's set axis to 1. So in vector Y, we are going to store our target variable. So creating this function ensures our machine learning model knows what to predict. Now let's write docstring for this particular function. Separate features and target variable. Parameters data, pandas data frame is input data, and target column that you can see over here, which is string, column representing the target variable, and it returns X, pandas data frame features, and Y, pandas series target variable. Also here, don't forget to return X and Y. Let me execute this cell and let's call this function. Let me copy this and let me paste it over here. Let's display column names. So this is our target variable that we have to pass as a string, and this function returns two values, X comma Y is equal to this statement. Let me execute this cell. Let me check. As you can see over here, our independent variables, and this is our dependent or target variable that we are going to predict. So now next, so let's first drop this unnecessary column, user ID columns is equal to this, axis is equal to 1. To modify our existing data frame, let me assign back. Let me check. Let's check docstring for this function. Let me press shift tab over here. You can see over here, docstring. So we have successfully created our function that will separate features and target variable that you can see over here. Now next, we are going to perform train test split. So let's create one function with name perform train underscore test underscore split. So here we are going to perform train test split just to evaluate the performance of our machine learning models. So here we are going to divide our data set into 4 parts, 2 sets, one for training and one for testing. So as an argument here, we have to pass independent variables and dependent variable. Let's set default test size to 20%. So we are going to keep aside 20% data for testing purpose. Also, let's set random state to 42 default value of this random state we have set to 42. So we have already imported train test split. Here we have to pass X and Y, and let's set test size to test size, which is entered by the user. Default value is 20% and random state to random state, again, which is entered by the user, but we have set default to 42. And here X train, X test, Y train and Y test. As I said, it will divide our data set into 4 parts, but 2 sets, one for training and one for testing. So we are going to train our machine learning pipeline on X train and Y train. We will perform prediction using X tests, which are our unseen samples, and we will compare our predicted result with Y test. So let's return X train, X test, Y train and Y test. Let's write docstring for this function. Perform train test split. Parameters X pandas data frame features, Y pandas series target variable, test underscore size float, which is optional. The proportion of the data set to include in the test split. Default is 0.20 that you can see over here. Next parameter, random state integer, again, which is optional. Seed for random number generation. Default is 42. This function returns X train, X test, Y train and Y test. Pandas data frame features for training. This is also pandas data frame features for testing. This is pandas series target variable for training. This is also pandas series target variable for testing. Let's execute this cell and now let's call this function. Let me copy this. Let me paste it over here. And as you know, it returns 4 part: x train, x test, y train, and y test is equal to this statement. Let me execute this cell. Let me check. As you can see over here. And these 2 arguments are optional. Let me remove this and let me run this cell once again. As you can see over here. Because we have set these 2 parameters with default values that you can see over here. As you can see, our X contains the original amount of data, which is 15,000. Let's check shape of our training set, 12,000. Means X train contains 80% of the data, which is 12,000, right? Let's check size of X underscore test. As you can see here, X test contains 20% of the data, which is 3,000, right? So this way we can perform train test split that you can see over here to evaluate the performance of our machine learning model in this project machine learning pipeline, because we are going to create machine learning pipeline. So we have successfully created these many functions: read underscore CSV, dataset underscore info underscore statistics, check underscore null, check underscore duplicates, plot underscore graph, sep underscore features underscore target, and perform train test split. Now next. So let's write new heading: column, transformer, and pipeline. Let's first create a column transformer and then we will build a machine learning pipeline. So instead of pre-processing each column separately, so we can use a column transformer to bundle different pre-processing techniques together. So let me show you this. So let me write column transformer and here transformers parameter. So in list, we have to pass Python tuple. Let's give name cat for categorical column and let's use ordinal encoder that we have already imported on gender column. Let me end this, and for numerical columns. So here we have used ordinal encoder for the gender column that you can see here. It's like assigning numerical values to categorical data. Think of it as converting male and female to zeros and ones. Now for numerical columns, we are going to use standard scalar. And here we have to pass each and every numerical columns available in our data set. Let me copy this column: age, height, weight, duration, heart rate, and body temperature. So you can see here we are using standard scalar for numerical columns. As you know, many machine learning models such as neural networks, SVM, k-means clustering, linear regression, logistic regression, etc. are sensitive to feature scaling. If features have different scales, the model might give more weight to features with larger scales. Standardizing the features to have a mean of 0 and a standard deviation of 1 helps to address this issue. So here we are ensuring that all features are equally important during the model training. So first here we have to write this site tuple. And here let's set remainder parameter of this column transformer to pass through. Let me execute this cell. Here is no colon, comma. So here we have to pass comma separated values in this particular tuple that you can see over here. So here adding pass through ensures that any columns not explicitly mentioned in our transformers remain unchanged. It's like having a do not disturb sign for certain columns. Let me execute this cell. As you can see here, we have successfully created our column transformer. Now let's build machine learning pipeline. So pipeline is a tool that allows us to streamline and simplify our machine learning workflow. In simple terms, a pipeline in machine learning is like a pipe that connects different stages together, allowing data to flow through each stage in a sequence. Means output of first stage becomes the input to the next stage in the pipeline. Let me show this. Let's use pipeline that we have already imported. Again, here Python list and tuple inside. Let me pass pre-processor. So let me assign this column transformer to one variable with name pre-processor. You can use any other name as well. Let me copy this. Let me run this cell once again and let me pass as a first stage of our pipeline pre-processor. And next model, let's use linear regression first. So as you can see, we have pre-processor. So this component is responsible for preparing our raw data for the model. As you know, this preprocessor is a sophisticated piece of code we have created earlier here using column transformer that we are passing as a first stage of our pipeline. As you can see, in the second stage of the pipeline, we are going to use a linear regression model. We will also explore other regression models shortly. As you know, our target variable is continuous, right? Calories, making this a regression problem. That's why we are using regression models. So let's assign this pipeline to one variable. Pipeline. You can use any other name as well. Type error. Let me check. Linear regression object is not iterable. Oh, here we have to pass this inside Python tuple. Let me execute this cell once again. As you can see over here. As you can see, we have successfully created our column transformer and a machine learning pipeline. Let's visualize our created pipeline. To visualize our created pipeline, we have to import from sklearn. Let's import set underscore config. Let me execute this cell. And in this set underscore config, let me set one parameter. Display is equal to diagram. Let me execute this cell. Now pipeline. This one. Let me execute this cell. As you can see over here. This way we can visualize our created pipeline using this module of sklearn set underscore config that you can see over here. Our preprocessor, which contains column transformer and one model, linear regression that you can see over here. On categorical column, ordinal encoder. On numerical columns that you can see over here. And other columns pass through that you can see over here. So this way we can visualize our created pipeline that you can see over here. So this is our first stage of our created pipeline being the preprocessor, and you can see our second stage being the model. So this way we can visualize pipeline that you can see over here. So now next. Now let's train our created pipeline. So for that we have to use fit method on our training set on X train and Y train. Let me execute this cell. As you can see here, we have successfully trained our created pipeline. Now let's perform prediction using unseen samples with our created pipeline. And let me assign it to Y underscore thread. Our predicted results. Now let's use metrics like R squared and mean absolute error to assess how well our model performed on the testing set. We have already imported R square score. Let me press Shift tab to check docstring of this function. Here we have to pass actual values and predicted values by our model. As you know, our actual values are available in Y underscore test and predicted values that just we have stored in Y underscore thread. Let me execute this cell. As you can see here, R square score around 96%, which is good. Also, let's check mean absolute error. So for that, we have to import from sklearn.metrics. Let's import mean absolute error. And here also we have to pass actual values and predicted values by our model. As you can see here, 8.44. But we are not stopping here. We are taking it a step further with cross validation. So we have already imported k-fold. So let me write k-fold, and here we have to set n underscore splits to 5 because we are going to perform 5-fold cross validation, and shuffle to true, and also random state to 42. And let me assign it to one variable k-fold is equal to this statement. Let me execute this cell. As you know, we have already imported cross underscore val underscore score. Here we have to pass our created pipeline, our independent variables and our dependent variable, and cross validation to k-fold, this one that just we have created, and scoring R square. And let me assign it to one variable cv underscore results is equal to this statement. So this involves splitting our data into multiple folds, training the model on some folds and testing on others. It's like giving our model a comprehensive exam. Let me execute this cell. As you can see here, results after each and every fold. Let's find average of this. As you can see here, which is also around 96%, which is good. So now let's create a function so that we can evaluate different machine learning models without repeating this code again and again. So let's create this function over here with name model underscore scorer. You can give any other name as well. So here let me pass model underscore name. and model, two parameters, and we are going to store output in one list. And output dot append model underscore name, and let's use our created pipeline. Also train test split. Let me copy, let me paste it over here. Also we have to train our pipeline first. Let me paste it over here, and then after we have to perform prediction using our created pipeline. Now output dot append R2 score. Let me copy this and let me paste it over here. So we are going to append R2 score for each and every models in this particular list, and also this mean absolute error into this list as well. Then let's perform k-fold cross validation. Here we are performing 5-fold cross validation. Let me copy this cross val score over here, and let's append this mean score to our list. This one, cv underscore results dot mean. This one. Let's return output. Let me execute this cell. So now we have successfully created our function model underscore scorer. Let's create one Python dictionary with name model underscore dict. So first linear regression, then RF for random forest regressor that we have already imported, and XGBR for XGBoost regressor. Let me execute this cell. Then let me write for model underscore name and model. In this dictionary dot items, let's call this function that just we have created model underscore scorer. And as you know, here we have to pass model underscore name that we are passing from here, and model, this one, linear regression, random forest, and XGBoost regressor. And let's store output in this particular list model underscore output dot append this. Let me execute this cell. Sorry, here is output. Sorry for this. Let me execute this cell once again. Let's check model underscore output. Let me execute this cell. As you can see over here, as you can see, it is giving same result. So we have to check. Okay, so here we have to pass not specific model but model parameter that we are getting from here. So let me execute this cell as well, and this cell as well. Now let's check output. Now it's correct. So as you can see here, first we have appended R2 score. So this is R2 score linear regression, R2 score for random forest regressor, and R2 score for XGBoost regressor. So this is R2 score, mean absolute error, and average of R2 score after cross validation. So from this result, you can see that when comparing R square score, mean absolute error, and the average of R2 score or R square score after cross validation, XGBoost regressor is the best model for this data set that you can see over here. So we are going to use XGBoost regressor in production. So let's train our best model on the entire data set. Before moving further, let's write docstring for this function as well. Evaluate the performance of a machine learning model using R square score, mean absolute error, and cross validation. Parameters model underscore name, which is string name for the model, and model machine learning model, the model to be evaluated, and returns output. It's a list containing model name, R2 score, mean absolute error, and cross validation R2 score. Let me execute this cell, and this cell as well. Let me press Shift tab to check docstring of this function, as you can see over here. So it is always better practice to write docstring for each and every functions that you can see over here, so other users can understand what this function is doing, parameters to pass, and what it returns. Now let's move on. Please remember, we have used train test split just to evaluate the performance of our machine learning model. But for production, we have to train our best model on entire data set. So let's first copy code for our pipeline. Let me copy. Let me paste it over here. In place of this linear regression, we have to use our best model, XGBoost regressor. Let me execute this cell. So we have successfully created our pipeline with our best model. Now let's train our pipeline on our entire data set. Let me execute this cell. As you can see here, we have successfully trained our created pipeline with our best model on entire data set. So as you can see, I have created this pandas data frame to perform prediction using our created pipeline with our best model. So let me write pipeline dot predict this sample. Let me execute this cell. As you can see over here, calories burnt value for the person having this personal details that you can see over here. So this way we can perform prediction using our created pipeline with our best model that you can see over here. Now let's save our model, means our created pipeline with our best model, XGBoost regressor. So again and again training is not required and we can perform prediction using our saved pipeline. So let me import pickle with open pipeline pkl. You can give any other name as well. So we have to open write binary sf.pickle.dump pipeline f, this one. Let me execute this cell. As you can see, we have successfully saved our created pipeline. As I said, we can perform prediction using this saved pipeline. Let me show this. Let me copy this. Let me paste it over here. Now we have to open this file in read binary. In place of this, we have to write pickle.load f, this one. And let me assign it to one variable pipeline underscore saved. You can give any other name as well. Let me execute this cell. As you can see here, we have successfully loaded our created pipeline. So we can perform prediction using this saved pipeline. Let me show this. So we have to write pipeline underscore saved, this instance dot predict. Let's use this data frame sample. Let me execute this cell. As you can see here. So this way we can save our pipeline and this way we can perform prediction using our saved pipeline that you can see over here. Now next, as you can see here, I have created GUI for this project. Exactly same way as we have created for our previous projects. Let me execute this cell. You can see here our GUI that I have created using TK inter. Now let's perform prediction using our created GUI. Let's select male 68, 190, 94, 29, 105, 40.8. Let's press this button predict, as you can see over here. So this way we can perform prediction using our created GUI that you can see over here. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye bye. See you in the next video.